All right, so thanks for joining the workshop day 3. So today, yesterday we talked about some sentence like while loop and break statement, and introduce vectors and high-dimensional matrices and cell arrays. And at the end of yesterday, we talk about functions and how to load file and to use function to package the code such that we can load file and do some operations and get some output. So the hardest part is the function. How do we deal with function? So remember how to define function and write what inside the function, pass the argument inside, and get some output to pass the output back to the outside. So today could be a bit easier. We're going to use MATLAB to plot. So most of time today will be you to try to plotting, right? So this is like a trial for you. You can play with this plotting to finish some major styles of plots like line plots, surface plot, and different violin plot. So these different kinds of plots are widely used in our scientific research. So today, well, most of the part will be like plotting, and then we will I will introduce a real example of using the code MATLAB to analyze some real data, and in the end we will have a quiz, final quiz. Okay, so we start with plotting. So if you have the MATLAB open, and could you please get into the folder of day 3 students and open the example 19 to run the code to plot a figure, and then change the figure to y equal to x squared instead of y equal to x. So y equal to x will be line plot. You change it to be x squared such that it becomes a quadratic plot. Please try this in your own MATLAB by open the example 19 in day 3 file. All right, have you get the answer? Or do you have problems? Oh, great. So this one is just to change the plot. So if you just run this code, you will have a figure. I don't know whether you can see figure on my screen. So it's this one. So, and then I want to change it to x squared. So instead of y equal to x, I should have x squared So would that work? You can try this. So it says didn't work, right? Because so this is actually a review of what we talk about in day one. So X now is a vector, right? So this is a definition of vector from 0 to 100 with step length 5. And once you have a vector is basically a 1 times some dimension matrix. Once you have a vector or matrix and you do the product, then you need to mind whether it's matrix product or dot element-wise product. Right? So if it's matrix product, then the X, remember X here is like a 1 times 20 dimension matrix, right? Maybe 20 or 21. So this is the dimension of X. And if we times another 1 times 20 dimension matrix, this matrix product is not valid because the dimension does not match. So similar here for the square product square, because square is basically X squared is basically equivalent to X times X, right? So, but then if you do X times X, the dimension doesn't match by matrix product. So instead you should use dot star, doing an element-wise product, and dot square. Right, so here should be dot square. And then now you have a result. So here. So just this is an example to show that whenever you do some operation to a vector or matrix, you need to know their dimension and you need to choose the correct operation based on their dimension. Right, so I think this task itself is easy, but it's a recap of we talked about vector and matrix. Okay, now you can try to change the size of X. You can change the boundary of X and the step length to say how the figure will visualize differently when you play with this, the step size of X. So when I increase the step length, it becomes smoother, and so the curve becomes smoother because you basically have more points, more data points on this curve. And you can click here, you see that this is the X value and Y value. If the X is has smaller step length, then you have more data points, which becomes smoother. But on the other hand, you also need to remember that, of course, more data points give you higher resolution or smoother curve, but it also take more memory, right? So there is a like trade-off. You cannot have too much points. I can, for example, have the step length to be 0.1 and even 0.01, but then I will have millions of data points for this vector. Right, so then it will probably take up a lot of memory, so which is I do not want. So this is the choice when you code. You want have certain resolution, but not too much, to consider in the memory. Okay, so that's for this easy task of plotting. So now you can go to example 20 and plot this, just run this code and make it to be sin x instead of cosine x, and improve the resolution. Because you see the curve I plotted here, it's very coarse. It's not a cosine or sine curve. It's like a piecewise linear plot. Okay, then we just trying to do it here. First, I change it to be cosine. In order to improve resolution, I just make the step length very small, so that I can run the figure. I run the code and get a figure. Right, so it's very smooth. So that's an example where you can see that the resolution of the figure doesn't matter if you have a complex shape of curve. So by the way, if you have a lot of figure plotted, you also take up memory. So you can close all the figures. So once you close all, you will not see any other figures. So, all the figures are closed. So you have freed up memory. So this is, I think it's also easy. And you can also make multiple plot. You can open example 21 and plot, run this code to plot the two curves together. And the task here is to add another curve such that it can plot three curves, curve 1, 2, 3. And the third curve, you can plot y equal to 2 times cosine x. Please do this in example 21. Okay, we see here we can add another plot. And the simple thing is we just do another plot. Right? We just copy the other plot and 2 times cosine. So notice that here cosine x is a vector, right? Because x is a vector. However, you times it with a scalar value, so you don't need to use dot product. Dot star will be the same as star here, so both are okay. So now you can plot it. I got a figure, so you see the figure here. And so you see the figure which has 3 curves. So here has legend, right? Curve 1, 2, 3. You can change the name of this legend in this legend here, right? So each legend will be a string. You can change like this one to be sine, then it will just show that the first curve is sine. And when different legends you want to name it. So this one is also not very difficult, but just to notice that we have used the hold on. So this hold on means to plot the following curves on top of the other figures. So if you do not have hold on, you can try. And then it will only plot the last plot. In this figure, it only have the last plotted curve in your code without keeping the previous curves. So having hold on will keep all the curves. Any question so far? I think compared with yesterday's function, these tasks today are much easier. And so you can also feel if you really made progress if you feel this plotting are easy. Okay, now you can open example 22 and please adjust the axis value to show the figure. Right, so I have a hint here. Axis small bracket is a function, and then middle bracket is to provide the whole first argument for this function. And then this argument is a vector, 1 times 4-dimensional vector, with each element separately denote x low, high, y low, y high. And so that's the 4 boundary of the figure you want to have. So the goal here is to resize the scope of this figure to have x from 0 to 10, y from -2 to 2. So please do this in example 22. Okay, now here it's also not difficult. Right? So here you just need to change the y to be -2 to 2. So here on this, you see the figure here. So basically you x from 0 to 10, y from -2 to 2. So this just tells you that you can choose the range of the figure by using axis. Alternatively, you can separately choose x range by having x limit. Now you just put the x boundary, right? And then have the y limit. to have minus 2. This will be the same as axis. Right. So the advantage of x limit and y limit is you can separately define the boundary of x, y axis. Right. So those are, those are just the small techniques. When you plot more, you can learn from that, because when you plot figure, you have some you want to make the figure look better, right? So then you will have some design on this figure. Then you will get to know how to do this adjustment. Okay, you can also adjust the length, the width of the curve, the color, and the font size of all these numbers and words in the figure. Right. So please try example 22. Try to change the width, line width of this figure, of these curves, change its color and change the line shape, right? So based on the slide here, by looking at this slide plot XY, I have some code of changing the width. Just play with those by yourself to say what to change for this figure. Okay, here we can just change the line width, right, like 3 or even more. So here G means the color, right? So G means green, so it gives a color. And this 2 dash here, it means it's dash line. If I have 1, it's a solid line. If I have red, then it's a red solid line. And so different colors here. And if you want to change the font size, I remember there is a code like GCA font size. Maybe I can change to be larger. GCA basically means all the figure, get a caption of all the figure. Right, so you can understand. So all the font size inside the figure will be changed. So we can try. Okay, so you say that this one becomes very big, right? So every number and word becomes bigger. Curve becomes thick. And because we didn't specify the axis here, so it doesn't show the full figure. But you see that the font size and the curve, the shape of curve, the width of the curve color have been changed. So that's a lot of option you can play with. So here I just also want to introduce, you can search plot here, right? Click plot, it will open a documentation. So now you see the documentation. It will have a lot of options to choose. You can drag down. There is a many option to tell you, what markers you want to use for the points, what line style, like sorted line, we just introduced, dash line, right? So many other different lines, color. So these are basic colors. You can use a single word to change the color for these basic colors. There are more colors, but you then need a bit more advanced way to give the color. So color is basically a 1 times 3 dimensional vector due to the RGB format. So many options you can try. Whenever you want to try this, just search plot in this in the documentation, and everything, probably most of the things you want can be found there. Okay, now I want to close all the figure I have so far. All right, next is we have subplots. Please open example 23 and do this subplot. There is one task that to adjust to add a third plot and do some adjustment to the third plot. Right, so now we only have 2 subplots, make it to be 3. And plot tangent dx and legend, adjust axis. Please try this in example 23. Okay, so here we just end the third plot. So subplot, the first 2 means how many rows and how many columns for this figure you want to have a subplot. 1, 2 means you have 1 row and 2 column panels for this subplot. So if you want to have third, you need to change the first 2 number to be 1, 3. So you have 1 row and 3 column panel. And the third number is to specify the number of the panel, 1, 2, 3. So this third will be 3. Okay, copy that to make it third panel. Can plot tangent dx. Just the y-axis to be, and then with the solid line, so dash dot line. Let's see how it looks. So you will have this way. And also I didn't put legend here, but you can put legend. So this will have the 3 panels. So legend, you just need to add legend after this plot. So also here, notice that we have a legend. Inside legend, we have an option called location. So whenever you use an option for legend, you first need to specify what the option you want to give. So here, the option is location for this legend. And what location you can choose. There are several different locations. North outside is just the north outside of the figure. Right, you can do this by search legend in the documentation. There, you see that you can put legend in different positions. Let's drag to the bottom. And so here are these positions you can put. Typically, I will use best. So best means it will put the legend at the position where it has less overlap with the plot. Sometimes you have a crowded figure, so then you can simply have, if you're lazy to adjust it for or just a legend position for different panel, you just put best. So therefore, then it will automatically make the legend to the blank space. All right, let's go back. Any question so far? Okay, all right. If not, then this is what we just mentioned. Now open example 24 and do the bar graph. And make the bar width to be 0.5. And on the same plot, plot the red line with the mean value of all the bar values here. Please try this in example 24. Okay, so here it's not difficult. We have a hint here. You just need to change the second. You add a second argument to the bar. So bar is a function to make bar figures. And just change the second option to be 0.5 to specify its width. And also plot a mean. How to plot a mean? You just plot. I think you can plot the mean data. Right, so mean data, it will be return a mean value for a vector. Right, so let's try this to see whether it works. It didn't work. Let me. So here is the bar graph, and we should. Oh, sorry. By the way, we should have hold on here, such that the mean will plot it on top of the bar. And in order to plot the mean, I also need to have one specifies x-axis, and so I have. Let's try this one. Okay, so I have here like some figure like this, right? So I have a mean curve on top of the bar graph. So here I have used the x value from 1 to the length of the data, which is 4. And I also have the y value to be a vector with all the elements to be 1 times the mean of the data. Right, so this way I have xy plot xy. So this is x, this is y. And of course, this is not the only way to do this. I just make a way to have the mean on top of the bar. You can also make the x range larger, such that the line becomes longer. Right? So this all the things you can do by change the xy axis, xy data of the in the plot. Right. So here we see we have a different way. Here we first get the average. We plot the x is 0, 5. Y is the mean value and mean value. Right? So you will connect 0 and 5 for the x point, and mean value and mean value for the y. So which will give you this line. So that's how we plot the line on top of bar. So we can also generate a distribution. So such as normal distribution. So we can use normal rand. Normal rand means a random distribution from random sampling from a normal distribution. You can search the documentation normal rand. So first argument for this function would be its mean. And second is the variance of the Gaussian. And third and fourth will be the dimension for the data you generated. So for example, exp1 here would be a normal distribution with mean 0, variance 1, 1,000 times 1 dimensional vector. So once you try this, you can also histogram this random generated distribution called hist. You can also use histogram. So both are okay. So now then the MATLAB will automatically do the histogram for this distribution. And you can also plot the two histogram together, right? Please try this in example 27. And you can change bins, histogram the bins to be 100 rather than the current one. Try this in example 27. So this one is also not very difficult. So here you just need to change the second 50 to 100. So then you see the figure has finer beans, right? So if you know, I mean, in terms of plotting histogram, different beans will give you a very different visualization on the data. If you have 10 beans, let's try 10 beans, you see the figure is like this, right? So then you will probably conclude that the histogram, the distribution is unimodal, like the yellow one, you see a single peak here. Right? But if you plot it with more beans, you see this yellow one seems to have 2 peaks here, or even more. Right? So the number of beans is really tricky to give you a very different visualization on the histogram. And you can also, sample different from different distribution. Here we use lom-rand. You can use random-n. Random-n is also a normal distribution. It's a standard normal distribution with 0 mean and 1 variance. You can also use rand. Rand is a uniform distribution from 0 to 1. So you can search the documentation for this one if you want to randomly sample. So random sample is useful when you want to initialize something. Right? So you want to initialize like some initial condition. We want to simulate some equation. Like initial condition can be random, has some uncertainty that you can random sample from a distribution. So now we are going to download the online package to do a violin plot. So this practice will help you to know how to download package from online and to use that package to do some task. So this will be extremely useful because nowadays many of the packages are developed. You can use it by downloading. So the package here we want to download is called Violin Plot. Please search on Google Chrome if you have internet, MathWorks Central Violin. MathWorks Central Violin. And then get into that, you get into the web page. So MathWorks Central Violin. And get into the website, and there should be a option download. There may be an option that need to sign in. You can just register account. This is a mathematical, this is a MATLAB account. You can register free, and after that, you should be able to download this package. With download the package, you can put this downloaded file, which is a script, into the current folder. And then open example 28 to plot. All right, so remember, search mathematics central link, central violin, and then download package, put into the current folder, and plot in example 28. So please try this. This is a practice. And meanwhile, we can have a 5 minutes break. We go 5 minutes. If you finish this, take a break. Okay, so here, have any of you have problem on downloading the package? Okay, I think it's should be easy, right? So the only thing that need to pay attention is after you download, you need to unzip the file, and then you will have folder, right? So in this folder you have violin, and then you need to copy the violin file into the current folder. So only in the current folder, then the MATLAB will be able to use this file, use this script. Right? So that you can click the script, you see that it is someone write a function. Right? It's like the function we wrote before. It's just someone write this violin plot as a function. Right? So you can actually learn something from the code here, right? If you want to. But as users, you don't need to mind that much. You just need to know how to use it, right? There should be some documentation inside the script you read and how to use it. So here we just use it to plot the two distribution. Let's see how it looks. Let's see, it gives you a beautiful figure of violin distribution. And beautiful, I mean, it's better than we just have 2 lines of code to plot simple figures. So this one is an example of using the distribution, using the package. And alternatively, you can also, so here we put the file into a current folder, but maybe sometimes you have a package that have many functions, many scripts. So then you don't want to put all the files into your current folder to make it a crowded folder. Then you can also do this, I think, by home. There is one option called set path, right? So here you see set path, and then you have this panel, and then you can choose end folder, right? So end folder, violin, right? So click this folder, and then it tells MATLAB MATLAB can use the script in that folder. Right, so here you see MATLAB has all the folders here. It's in MATLAB toolbox. Right, so those are the built-in function we used, which have been installed into the toolbox. Right, so MATLAB will search these folders for those built-in function like ones, zeros, size. And so all these built-in function are put in some folders we just shown, and you can add more folders with the script. Okay, so that's for this example. And we can also do another, use another package called the distribution plot. Right, so if you want to try, please go to website to search distribution plot.m and get into this website and download this package to finish another distribution plot. Use distribution plot, download the package and use it in example 29 to plot the distribution. So I have just downloaded the distribution plot here, and I need to unzip to have the folder, right? And then I need to, the best way now here is to really add this folder into my package, right? So I add this folder. And this folder, which is distribution plot. I select and I have this folder added. So now I can use a script inside. I don't need to put them in my current folder. So let's try, and we can use distribution plot now. Right, so you see I got a violin distribution. Now, of course, now it doesn't look very good because it's blank, but you can adjust the color by reading the documentation of this function. Okay, so the key here is just to load this script, this package by adding the path of this package. Okay, any question so far? If not, then here we see that the distribution plot has many options. Right, you can show the histogram on the left or right, specify its color and how wide, whether show the median value, right? So all these options can be played with and to choose how to make this violin plot. And when sometimes we also can subsample the data. Right? So one this function is called random permutation, randperm. This is just to subsample from a given data set. Right, so the way to do this is we first randomly generated experiment 1, 2 from a normal distribution. Then we random per its length, the value, how many random numbers are there, but we just sampled 10 out of it, right? So the random per first is what's the size of your random sampling, and the second value is how many random number you want to sample. Right? So for example, here experiment 1 has 1,000 value, so I will randomly take value from 1 to 1,000. I will randomly take 10 value out of it. So this will be my rand index. And then I just put this random index into this 2 variable. Right? So this random index is 10 random number from 1 to 1,000. And then I'll just take those index from the 2 vectors as my subsample. Right? Please try this in example 30 and see what it gives to you. And then you can use plot spread to plot this random sample ones and plot its mean value. Right, please try this in example 30. Okay, we see here, which is exactly the code here. Right, you see that we randomly generate some value. right? You can actually show this value by using display. And therefore, you see that every time I run this code, it will randomly generate 10 values from 1 to 1,000. Right? So then rand index is a vector, 10-dimensional vector. I just take this 10 position vector of these two variables to get the subsample. And I use a function called plot spread to plot their spreading as a figure shown here. And so it's a spread plot. And I just also need to add the mean value for this line, which is exactly the same as we do in some of the early example. Right? So which will be just calculate the mean and plot the line. So like here, we calculate the mean and plot the line. Okay, then MATLAB can also plot 3-dimensional figures. For example, here, you can open example 25 and run it to see what it gives to you. And you can adjust the range of x, y, right, by mesh grid. Here, mesh grid means we have a square mesh for x, y, and then we use surface to plot the 3-dimensional surface. So you can also change a lot of options. You can try to change the different visual angle, shading, and color bar we will introduce in a moment. Please try to plot this in example 25 first. So now here you see I have a 3-dimensional surface plot. And I also add the code color bar, and then you will show color bar here. And so here I have a color bar. It shows color bar. And I can also change the different visual angle. For example, visual 2 will be like from the top to bottom. You see it will look like this. So you see the surface curve by its color scale. I can also change the different type of color. Shading interpret means I will change the way it shows those counter plot. Shading interpret means it doesn't show the counter, right? Like the contour, the mesh grid. So you'll see a clean surface plot. And lastly, you can also change the color bar. Here I use HSV, which is just a type of color bar. So I can run this, you see how it looks. I see the color scale change. Okay, so a lot of things to change in the 3D plot, right? So which are just it's just an experience. The more you play with it, the more you know what options you can change. Right. So for the color scale, you can search color map. Let's see here, color map, MATLAB, go to the documentation. Right, so here you will have all the color map in MATLAB. So here, the default is called Parula, and the HSV we just used had many different color map. Right, so this way you can adjust the different colors to give a different visualization for the colors. And then you choose the color map here. Right, so those are just tricks that you can play with to get a different visualization of figures. And lastly, everything you did in the code, you can do it in the editor. Like here we have an editor, right? So we have figure you can edit. You can, first of all, you can drag, you click rotate 3D, then you can drag it, right? So then you get automatically see a different visual angle. You can also, of course, zoom in, but choose this. Right, so zoom in, you see this was not plotted because the resolution is not too high. Right, so different, a lot of things you can also change by using tool and something, right? Insert the label or a lot of changes. So a lot of things to play with. Color. So everything you did in the code can be done in the in this panel, in this figure panel editor. Right. So it depends on how familiar you are with MATLAB. So like me, if I code a lot, I prefer to change these visual options by code. But I know some people maybe they didn't often code. They just directly get some code for the figure, but they want to change the visualization for their purpose for their preference, and then you can directly use the editor. All right. So far a lot of things to play with, so I just want to show you that some example of playing with the visualization of the figure. Okay, so that's pretty much all of what we want to cover for MATLAB basics. If you have any question, please ask now. And otherwise, we will move forward to the last part of introducing an example, very example of using MATLAB code. Okay, if not, let me quickly introduce an example of using MATLAB to predict the stock price. And this will be an practice, a good practice for you to test whether you can use MATLAB to solve real problems. And I will also use this as an homework. Right, so eventually, for those who register the course, there will be homework, and I will send you a assignment that has some task regarding to this part. Okay, so let me quickly introduce the problem and how do we do that. So when we talk about stock, of course, it's very complex, but one good example is called the Renaissance Technology Company. This company was founded like 20 years ago, and it was founded by a mathematician. And they can, with their very high expertise in mathematics, they developed some modeling strategy to do stock and predict. And you see that they have they have established a fund, and this fund, denoted by the orange curve here, has high rate of earning earning rate, right? So this one will, especially in the economic crisis around 2008, they can still have high income rate. Right? So this one shows that by using some model, there may be possibility to predict the price in by mathematical model. So, and there is some guess that this company use a model called Histograms model. Of course, it's their secret, but the mathematician, the founder, is an expert in Histograms model. So at least there should be some relation to this model for their trading strategy. So hidden Markov model is basically a stochastic model. So you have assuming some hidden states. So you visualize the stock price as a like several price state, right? For example, you can roughly separate the price to be high or low. Right? Maybe above $100 is high, below $100 is low. And every day the price will jump between these states. For example, from above 100 to get low to below 100, that will have a state switch. So you can have finer separation of the states, like every $10 you give it a state, so you have a lot of states. Right? So just different resolution on discretizing the states. But after having these states, this model tells that there is another underlying states, hidden states, which we don't know, but these hidden states will determine the visualized states, which is stock price. Right? These hidden states can be like people's emotion, or some politics, or some policy, or some marketing use. Right? So all these can be hidden states. Hidden states can also be different states. If you, for example, you can also consider like two basic states, whether the market is in high mode or is in depressive mode. Right? So if it's high mode, then the stock price today or tomorrow may tend to go higher, or otherwise get down. Right? So this is a basic idea of hidden Markov model. You have hidden state switching. Every day people's emotion, marketing news will change between different states. And on top of that, it will cause certain probability of the stock price to go high and low. So this is one of the schematic of hidden Markov model. You can have a bull state and bear state, which is hidden state. This hidden state will switch, right? Sometimes it's high, sometimes it's low. When it's high, then the stock price tends to get higher most of the time. When it's low, then it probably tends to get lower. Right? So that's the hidden Markov model. So then the goal here is to infer this probability of state switch by given some historical data. Right? So you do a model training by learn a hidden Markov model with those parameters of state switch. And then you assume that the market will follow the same switch for this hidden Markov model and then predict the future stock price. So that's the problem. It's very clear. We have stock price data up to now, up to the current second. And we want to use that data to predict up to certain future time, whether the stock is go high or go down by using this model. Right, so if some of you know, recent days, it's machine learning fascinating. This is kind of machine learning model. Right, you have data, you train model, and then predict by the trained model. Any question for this problem? Then the first thing is to download data, right? So because we want train model, the first thing is to download data. this can be realized by a package. So now we go back to what we learned in this workshop, to use package to extract data. So there is a package called Yahoo Finance Data Downloader. You just need to search this and go to this web page, download the package. And it has a documentation here. Right? So documentation how to use this package, the function inside this package. I just read the documentation. Now you can tell it which day, which stock price, and which data you want to use. You can use every day's data, whether it's a closed value, it's high value, or low value for certain stock at each day. So that's our data. So we can get daily data up to today, and for every stock in the stock market. Right. So this is download data. Everything is we learned in this workshop. You download package, and then you read this code, and you choose which data to use, and you plot the figure. Right here. So here is a figure of plotting the time traces as has a 3 legend. So once you have data, so here is my code of using this package to download data. And so it's not difficult. You can even make it simpler, because I also use this data for other purposes, so make it a little bit complex. But you can, the core code is just use this function get market data via Yahoo, and you specify which data you want to have, which stock you want, which data you have, right? And then you get a times series of the stock price. Okay, so once you download data, this is step 1. Step 2 is to train a model, right? So then MATLAB also has a package called a hidden Markov model. This is a package of implementing the model. Again, you read the documentation and see how to use this model. So the core code is also very simple, a line of code, HM train. Right, this seq variable here is just the time series you downloaded before. Then you can give it different variable name, and you also need to specify some initial guess of the transition probability, the probability of a state switch, right, between hidden states and between the emitted stock price. So these are just the 2 matrices. You can give arbitrary numbers, and then this function will use this data to train the hidden Markov model to get the probability. This probability here, you see the value here, that will most likely to reproduce the data. Right. So this probability before you don't know what's value for each state change. Right? So that but you give it the input data of some historical stock price, then it will infer the most likely transition probability to regenerate the data. So that's the function we did. So once you get to the model, then you can use another function to generate new data from the model. So this is my code of train model and generate the data. Basically use the HM train and HM generate. Very simple, a few lines of code. Right? You can even make it more clean. So my code again have other things to do, so a little bit difficult, but the core code is very simple, a few lines. Okay, let's see the result. So after that, I get a prediction, right? So first of all, I train the model and reproduce the data. Of course, you need first to plot the figure, right? So this is another thing we taught in the workshop, plot the curves. It's day 3, right? So I have the data, which is black here, which is a vector. I just plot the vector, right? So this is Apple price, right? Stock price. This was done like a few months ago. So then I have used around 30 days of historic data to train the model. Right? The data used to train was in this green box. And then I used the trained model to regenerate the regenerated time series. And you see that the regenerated time series matches the historical data very well. Right, this red and blue you probably didn't see, but it's overlap with red. Right, so red is close with the black in the box in the trained data region, which means that the model does learn the data, so successfully learn the data. However, when I use that model to predict the future, right, future 1 day or 2 day, then you see that the second day gets bad. The data shows the stock goes down, but the model prediction goes up, right, which is obviously different. So if you use this model to make stock, then you want to buy the stock, but then the stock is down, so you lose some money. So that's very unfortunately, the model didn't predict very well. Although it can learn well, it can learn the historical data well, which is promising, which shows some promising. And I repeat this model training and the prediction by doing many other stock. And so here I do another bar graph. If it's orange on the right, it's correct predicted. If it's blue, it's incorrect predicted. You see, I do Facebook, Tesla, many other stuff, Google, right? So, but most of the time it didn't predict well, right? So even though it can predict half well, half bad, but it's like random, right? So you don't have a significant statistic significance to say you have good prediction. So this tells us that, this model unfortunately couldn't predict the correct future stock price. So after that, I do some research, right, why it didn't work. So and I noticed that this company we just mentioned before, which probably used this model to earn money, and obviously they have a more advanced techniques. For example, they have a patent of probably 5 years ago, they got this patent of having the data for 1/billion second. Right, so you can imagine that what I used the data before is 1 day. Every day I have a data points, but they have data points every 1/million seconds. Right, so every second they will have 1 million data, and every day they will have 1,000 million data. So then you can imagine how much more data they have compared with I could get, or typical, normal people can get. All right, with this very high resolution of data, their model probably can work with a very short time scale, probably seconds, probably minutes, right? Because at that time region, maybe people's or market has some trend which can be learned by the model and successfully predict. Right, so this is one thing, they have much more data. And I also read there are some of their documentation that they did use hidden Markov model, but with adding more complex gradient into the model, like some other parameter layer to count for other factors in the stock. Right, so you can see that they have more data and they have more fine model. So that's why here, although I couldn't successfully predict the stock price, but there is hope to do that since they are money. But for normal people, it's hard to compete with this company. Right. So the lesson for this practice for me is that be careful to get into the stock market if you don't have a very advanced technology or innovation ideas of doing predicting stock. These companies are far better than we could imagine on predicting the stock. And so stock price is very complex. So before that, do you have any question? Okay, so stock price is complex, but what about biology? So in our lab, we also have biological data of some protein time series. And so this is what I use a model to learn the time series and predict the time series of regenerate the time series from the same model, heat map model. So the up panel heat map is a set of time series under different drugs. Right? So then the heat map, each row is a time series. So it has multiple time series aligned in as a heat map. The color is just their value. You see that the model can reproduce this data ensemble relatively well. Right? So at least you see that the different drug, the model can produce distinct behavior of this data ensemble. You can distinguish different drug by using the model. Right. So anyway, it shows that we can, by using model, sometimes for complex things it's hard to predict, but for more small data and more regular trend in the data, it may be possible to predict. So that's the lesson, a scientific lesson of doing this practice. But in terms of coding for this workshop, everything I just talked about this task, is what we have learned, what we have met in this workshop. So now I would say, if you could understand this workshop, you should be able to solve some real problem by using MATLAB. Right, so that's almost all for this workshop. And if you want to learn more, you can search this numerical computing with MATLAB to read the textbook, right? But I think the basic things that we have already covered. And my personal lesson of coding is that once you know the basics, you don't need to read textbook. You just directly go to do problems. And in the problems, you can search the code you need, and after some problems, you will be very familiar with the coding. Right? So now you know the basics. Just go to the problem directly. Okay, so that's all from this workshop. Do you have any question? Okay, if not, now I will soon send you an email link for the final quiz. So this quiz is difficult. It's not difficult. It's just a goal to evaluate how much you learned, how much you really learned from this workshop. So I will send you a link. It has 10 questions, and you can have 20 minutes, because previously I gave 10 or 50 minutes. And some of the students ask more time. So this time I give 20 minutes to do that. Just take more time if you want. And if you have the final quiz sent to you, and I also attach the final homework for the 275 students. Right? So this homework has 2 weeks due. You just need to send me it has instruction inside it. And that's all for this workshop. You take 20 minutes to do the quiz, And if you didn't answer all of them correctly, you can be longer. After 20 minutes, we will go through the quiz together. And then that's all the workshop. Okay, I just send you the final quiz by email. Yeah, actually, I can also put the link in the chat room if you want. "20 minutes to do the quiz, especially for 275 people. Right? It's this quiz will be material for evaluation. Right? It's not difficult. Just take time to do that. And the final homework is attached in the email. You have 2 weeks. Okay, so now 20 minutes.